Hi everybody, I'm the SolidWorks Nerd, and as some of you may know, I have been contributing to Every Kid Gets a Robot. This is a robot that currently costs just $18.95 to produce. And this increases STEM accessibility for all kids, no matter their income. Every Kid Gets a Robot is a project by Danielle Boyer in Troy, Michigan. She's an 18-year-old gap year student who wants to bring affordable STEM education to kids. She mentors and assists over 35 robotics teams and has used her passion to publish 5 STEAM-related books. Now, I've mentioned this in earlier videos, but I love this cause. And in this video, we'll go over some of the things I did to help print some prototype wheels. The first time I started working on Every Kid Gets a Robot was in January, when Danielle scheduled a prototype party to introduce the newest version of the robot to her all-girls first LEGO League robotics team. All sounds good until the date was moved up a couple of days by the participants, and she found herself with less than 2 days until the event, and had no parts at all. Fun times. Upon hearing about this, I offered to print and overnight ship the wheels while a student of hers printed out the bodies. My Markforged Onyx Pro was on standby, but I knew in order to get as many wheels as possible in the shortest amount of time, I would have to be strategic. Here's what I did to accomplish that. Let's take a look at the wheel that was sent to me. In SolidWorks, it is constructed quite simply. A shallow cylinder with some rounds, a groove to accommodate rubber bands for traction, and a hexagonal array that frankly just looks cool. But as rad as these hexagons looked, it wasn't really helping our situation. You see, when you put a hole in a solid model, you would expect the 3D print time to go down, right? It's using less volume theoretically, but a lot of the times the print time actually goes up. The reason for this is that instead of printing time-saving fill patterns like it normally would with no hole, it now has to spend time to construct the walls that are created with each new hole. In short, the more perimeters a part has, the longer it will take. The ideal situation is to remove the cutouts altogether, but we didn't want the wheel to look bland, so we settled for just removing the smaller holes along the edges of the wheel. There we go. I'd say that's a happy medium between print time and coolness. So with that out of the way, I could get printing, right? Well, another issue befell us. As much as I like my Onyx Pro, one of the main drawbacks is its relatively small build volume. I could only fit a handful of wheels before the geometry denied me any more instances. So what is one to do? Well, we build up. The Markforged software supports multi-body STLs, which means that I can use a Move Copy Bodies feature to make another instance going up. I left a 1mm gap between the two instances, which worked pretty well. This also means that the wheels will have reduced surface finish because it has to build support material between the small gap left between the wheels. But we just wanted the wheels to exist more than anything at this moment. I then threw the parts in Eiger and optimized the settings, namely printing at 200 micron resolution, the coarsest resolution, and setting the fill a little bit lower, and with that, I sent it to print. In the morning, I thankfully found the machine holding perfectly printed parts, ready to make an appearance at the party. I shipped it over, and as you can tell from these pictures, the party was a success. And with that, my work was done. Or so I thought. I looked into the machine and was coming to the end of a spool. I didn't really have any projects that used this little material, so I said, let's print out more wheels. Why not? So my next self-imposed task was to make a version of these wheels that consumed the minimum amount of material possible. I accomplished this by making 2 simple tweaks to the wheel. The first was to get rid of the fillets and replace them with chamfers. This eliminates the need for support material. The second thing I did was reduce the thickness of the center disc portion. It doesn't interface with anything, and the weight of the robot is negligible. It's just a battery and a development board, and you just gotta add the weight of the body. I also left in the sharp corners, as stress concentrations in that area did not concern me. This greatly reduced the material consumption, and I was able to get a handful more of these out the door. And that brings me to today, where I've come up with a slight redesign for the new printer that I bought at SolidWorks World. So this new design is geometrically identical to the penultimate ones, but is now comprised of 2 STL bodies of different colors. One is nested inside of the other. It is specifically designed to print on my new printer. If you would like to venture a guess as to what my new printer is, leave a comment down below. The project has garnered traction in the SOLIDWORKS community, having been the recipient of the Swuggan t-shirt fundraiser. Danielle's work has been featured on a multitude of platforms: the SOLIDWORKS blog, the 2018 SOLIDWORKS User Advocacy Day that I met Danielle at, and on an upcoming Born to Design podcast feature. She's presented at SOLIDWORKS World. And if you'd like to know more about Danielle and Every Kid Gets a Robot, check out the links in the description. So I hope you've enjoyed this video about what things you can do to optimize your 3D prints, and a small peek into the awesome project that is Every Kid Gets a Robot. This has been the SOLIDWORKS Nerd. Thank you for watching.